The last thing this unit's going to cover is, now that we know how to start with y equals a number or x equals a number, how can we instead write and get to that point if we're given something like a graph? So we started this unit learning about slope-intercept form, which is y equals mx plus b, where that m, or coefficient of x, is your slope and b is your y-intercept. So the problem is, well, what if your slope is 0, or what if your slope is undefined? And we've already learned a tool in the last video to help us with this. So we remembered these little abbreviations, and they're awkward at first, of HOI and VUX. HOI helps us remember that y equals has that 0 slope or a horizontal graph, whereas VUX help us remember that x equals a number has an undefined slope or a vertical graph. So as far as writing equations in that format, it really depends on what you know about the graph or the slope. So if you're given a graph and you see that it's a horizontal line, I can make that mental note, or even write it out sometimes, that a horizontal graph goes with HOI. And then that helps you remember that I'm really looking at an y equals number type of graph. As far as what number to put, it's whatever your y value is. So if we look at this line, everywhere along the line, the y value is 7. So that means our equation would be y equals 7. It's a horizontal graph because it's not moving up or down away from that. If you're given a table, there's a couple things you can do. First, you can start off finding that slope, so looking at the change in y and your change in x. And that might be when you notice that something a little funky is happening, because our change in y is 0. So a 0 slope also goes with HOI and y equals. Instead of a graph, though, we have the value that y is every time, and in this case, it's -4. Now, you might not need all of this work if you automatically see that your y value is not changing. If your y is staying the same each time, that is your signal that it's going to be y equals that value. So in the opposite, let's say you have a vertical line or an undefined slope. If you see a vertical line like this, you might want to think of the abbreviation VUX to help you remember that this is an x equals number type of graph. As far as what specific number you're going to put there, depends on where the graph is. So here this x value would be -5, and it's -5 throughout the entire graph. So that means our equation would be x equals -5. Then from a table, you might already recognize that something's weird is happening since our x value is not changing. But if you didn't and started by finding the slope, our change in y here looks like increasing by 4. And our change in x is not changing, so it's 0. At that point, when you set up your slope, you might realize that 4/0 is undefined. That undefined slope should be what leads you to x equals a number. And again, here you're going to use the value in that table. So this would be x equals 4. So let's go through one more of each of these. If you're just given the slope and y-intercept, if you're given the graph, and finally, if you're given a table. So normally these are the easiest when you actually have a numerical value of slope. If it's 0 or undefined, it gets a little tricky. So first thing I like to think of if I see a 0 slope, again, is going back to that HOI, 0 slope, to help me remember that it's y equals a number. Here it says the y-intercept is -3. If we think about what that would look like on a graph, -3 would be down here with a slope of 0 is a horizontal line. So we can see that the y-intercept is the same thing as the y value of the graph. So my equation would actually be y equals -3. By comparison, if you have an undefined slope, and that abbreviation of VUX, you won't have a y-intercept unless your x value is 0. Because it's a vertical line, and it might not actually pass through that axis that it needs to. So instead, they're going to give you a point. And if we think about points and why that helps us, we know we have x equals a number since it's an undefined slope. So if we think about the point, we need the x value from that point. So here, a vertical line passing through 7, -3, x is always going to be 7. A little bit easier, at least if you're a visual person like I am, would be if you're given the graph. So here we have a vertical graph. So I'm really focused on my x value that's not changing. So this would be x equals -5 since it's at -5 on the graph. If I see a horizontal line, I'm thinking hoi or y. So y equals whatever value it's at, which is blocked but looks like 8. And then finally, if you're given a table. We talked about 2 ways of doing the table. First would be if you notice right away that one of your values is not changing. That's going to be whatever value isn't changing. So this would be x and the value that it's staying. So x equals 2 here. Or your other way would be if you don't notice that right away and you just start off by finding the slope. So here my change in y is not changing, where my change in x is increasing by 3. So my slope would be 0/3 or 0. That might be the moment that I realize that this is a special case scenario of y equals, since it's a 0 slope. So then I would say y equals whatever my y value is, which here is -4.